Hi folks, in this video we're going to learn how to graph exponential and logarithmic functions. Now, a lot of this is going to involve some transformations, and what I have here are just the rules for transformations just to help you recall what those are. Now, it does not matter what the base number is here, so long as it's bigger than 1, all of these rules will apply. Remember, h shifts the graph left or right opposite the sign. So minus actually moves it right h spaces, plus moves it left h spaces. K moves your graph up or down however the sign says. So if it's positive, it's up k spaces. If it's negative, it is down k spaces. Okay, you're welcome to freeze this and copy all this down. However, we are ready to move on in order to keep this video as brief as possible. So here I have a graph, and what we're going to do is we're going to use a table to kind of help us out with some points, and then we're going to transform those points. Okay? So what I'm going to do is I'm going to start with the basic function without any transformations. So that would just be 2 to the x. So I'm just going to plug some numbers in for 2 to the x. You want one of them to be negative. Negative 1, 0, 1, 2. And if you want to fill in a third one, hey, I don't care. Okay? But that as long as you have at least 3, you're in good shape. Now, if I plug these in using the calculator, I will get 1/2, I will get 1, 2, and 4. So I'm ready to graph what they would call the parent function. So negative 1, 1/2, so just up a little bit. 0, 1, 1, 2, 2, 4. So, here's what this graph approximately looks like without any transformations. Okay, so that's without any transformations. Now, what I'm going to do is I'm going to transform this function. So I look at this, and using the rules from the other sheet, since this says minus 4, I'm going to move it right 4 places. And then because it says plus 1, I'm going to move it up 1. So now what I'm going to do is I'm going to take these points and I'm going to move them right 4. So if they go right 4, that means I'm actually adding to this. So negative 1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, and 2 plus 4 is 6. Now I need to move them up 1. So I'm going to add 1 to each of these numbers. So 1 and 1/2, 2, 3, 5. So let's get graphing. So 1, 2, 3, up 1.5. 4, 2, 5, 3, 6, 5. Right here. Now, I could have just taken my points and gone here, right 4, 1, 2, 3, 4, up 1, and been okay. Done the same thing here. 1, 2, 3, 4, up 1. 1, 2, 3, 4, up 1. Okay, that works too. You do not have to use the tables. Okay, you do not have to, but you have to have at least 3 points plotted. So I'm going to attempt to draw this in. Okay, now I'm going to try to extend mine all the way out. Now, the domain are the x values that work for this. So this is going to keep getting wider and wider. So that means it's going to be all real numbers. The range, however, the graph starts at, I start seeing a graph at y equals 1. But remember, it doesn't actually touch 1. So that's greater than 1. And we know it doesn't actually touch it because this line here that it approaches is called an asymptote. And because this goes through the y-axis, our asymptote is y, then equals 1. Okay, that graph is finished. Okay, you need to have all of this information. Now, sometimes you may only have one transformation, and that's okay. And so you would just list only one. But those are the basics for graphing an exponential function. Now, for graphing a logarithmic function. Now, here I have a problem, and this is log base 2, and the printer kind of cut that off a little bit, so we fixed it. There we go. Now, this one is kind of tricky. We don't actually graph log functions straight away. Alright? So what I'm going to do is I'm actually going to graph the exponential function first. Okay? So, because this is log base 2, I'm actually going to use my chart to find 2 to the x. Alright? So, I'm going to start off with those points. -1, 0, 1, 2. Use my calculator. I can type this into the y equals and make it give me the points. Okay. That's 1/2, 1, 2, and 4. Now, here's why we use the exponential. Because I can figure this out in my head. Okay? What I can't do is I don't know logs in my head. But I do know that exponentials and logs are inverses. So my non-transformed log function is this flipped. So there is a purpose to this, okay? So flip these. 1/2, -1, 1, 0, 2, 1, 4, 2. Alright? So this is actually what I'm going to start with here. But then I'm going to transform. Okay, I'm going to transform it by, because this is +3 with x, that actually means I need to move it left. So I'm going to move left 3 places. Because this is -5, I'm going to move down 5 places. Alright? So now, you can either adjust your table to reflect that, meaning take away 3 from the x's and take away 5 from the y's. Or you can plot your points and then physically move. Okay, I do not care which one you choose to use. Okay, for clarity, I'm going to fill out this other table over here. Okay, so since I'm going left, I'm actually taking away 3. So that's 2.5. 1 minus 3 is, that's -2.5. 1 minus 3 is -2. 2 minus 3 is -1. 4 minus 3 is 1. Now I'm going down 5. So I'm going to subtract 5 from my y's. That's -6. 0 minus 5 is -5. 1 minus 5 is -4. 2 minus 5 is -3. Okay, so I'm going to plot this just to give you some clarity. So 1/2, -1, 1, 0, 2, 1, and 4, 2. So I'm just going to draw that in. Now, those points I can move left 3 and down 5 if I so chose. Or I could just straight up plot these. I do not care. So, -2.5, down 6. -2, 5. -5. -1, -4, 1, -3. Let's see here. -1, -4, 1, -3. Oh, I made an error right there. There we go. Because, let's see here. 1, -3. There you go. So this point should not be there. Oops. Guess I made a mistake. It happens. Okay, so now I'm going to connect these. And this one's curving down. So I could just now take these points, left 3, 1, 2, 3, down 5, 1, 2, 3, 4, 5. There we go. And I could do that. So now I can look at the domain. Now it does not look like this goes forever in both directions. So because of that, the domain is not all real numbers. It looks like it starts moving from left to right. It looks like it starts right about here at -3. So x has to be greater than -3. The range, it definitely goes down forever, and it looks like it's slowly going to keep going up forever. So the y's are all real numbers. But that pesky asymptote, well, it's whatever the graph approaches but never touches, and that is -3 in this case. And asymptotes are demonstrated with dashed lines. So this touches, the asymptote touches the x-axis at -3, so the asymptote is x equals -3. Now, again, I do not care which method you choose, whether it's use all the tables or whether it's just move the box, move everything after you plot the points. I don't care. But I hope this is beneficial to you and helping you study. Thank you very much.